Hello everybody, I will start my today's another live coding session. So in my today's video, I will solve this question. Flatten binary tree to linked list. Given the root of a binary tree, flatten the tree into a linked list. A linked list should use the same tree node class where the right child pointer points to the next node in the list and left child pointer is always null. The linked list should use the same tree node class where the right child pointer to the next node in the list where's the right child pointer? Yeah, the right child pointer is always null. So, okay, I see. One is pointing to 2. And the linked list should be in the same order as a pre-ordered traversal of the binary tree. So when I do the pre-ordered traversal in the example 1, it should be just as labeled 1, 2, 3, 4, 5, 6. So it should be sorted in this order. I see. Sounds quite simple. So seems like I just have to do the pre-order traversal, and in that order, I build the linked list. Okay. And it says the linked list should use the same tree node class with the right child pointer. I see. Okay, so I cannot create a new linked list. I don't initiate the new tree node, but I will use the tree node included in the given, binary tree. So I think that's one of the conditions I have to meet. Okay. So let me start with the clarification of this question. So in this question, I'm giving a root node, but I don't return anything. And as a kind of side effect, I will modify the tree. And in other traversal, the root node should always come first. Sorry, pre-order traversal. Yeah. So the root node, given root node becomes the first node in the linked list, or it's just a head node. Okay. Aside from that, I'd like to clarify something. Root can be known. Yes, so in that case, I should return anything, and I don't do anything. Yeah. Okay. So let me think of this question with an example. So in this case, what I have to update is the tree node should be like this. And for the left node, because what should I say? So the left child should be always pointing to null. So I represent x as null. X is null here. So it should look like this. Okay. So yeah. I think what I can do here is I do the pre-order traversal and each node. Wait. I think I just have to keep track of all the nodes in this order, in that order, into the list. I don't have to take care of the pointer for now. And then for each node in this list, Firstly, I change the right pointer of this first node to the second node and left pointer to no, and do the same for second node. Second node should second node right should be pointing to node 3, and second node dot left should be null. I think I can do it, yeah, iteratively. Yeah, I think this can be the brute force approach. So firstly, I do the in order traversal. Then I do the pointing, concatenating. So it should be overband time complexity. Good. For space complexity, so it depends how I do the the traversal. But oh yeah, the traversal basically needs overband space for the kind of recursion stack. And also I need the list for the nodes in sorted order. So it should be overband. Okay. I think this is good enough. I cannot optimize more than O of n because at least I have to visit each node to update the pointer. Yeah, I think this is good enough. Okay, so let me get started with the implementation. So quickly I will sort out. So I do in order traversal and build sorted nodes with and concatenate nodes in sorted nodes, and I will return. Okay. Node in order, let me change, in order traverse. So I guess the sorted nodes. And what I will do next is for nodes, let's say, for this one, it should point to node I plus 1. But for the last one, it should point to node null. I have to take care of it. So in this case, yeah, for the last one, it should be pointing to none. And also I have to update so left pointer. Yep. Good. Okay. Maybe I can write it in a single line. Like this. If this is the Rust node, it should be pointing to none, otherwise the next node. Okay, that's it. And the last thing I will do is doing the the traversal. So yeah. Okay. So let me change a little bit and make this a shared variable. This way. And now in this the traversal, I append the nodes into this self.sorted nodes. Recursively. This is the base case. First we put the root and then recursively call this and this. In this way, the root node is always taken first. Then I will take a look at left subtree, then right subtree. Yeah, exactly the the traversal. Okay, I finished my implementation. Now let me walk through my code. The first case I'd like to check is if root is none. In this case, I should do nothing without an error. So in line 45, the node is an set, and in the traverse method, because root is none, it immediately array returned, and that's it. And number of nodes is 0, so in this for loop, there's no step. That's it. Okay. I passed this test case. Good. So let me just take a look at one example here. So in this case, what is expected is obviously like this. Yep. So in line 54, or I should say in line 55, I should initiate the traverse. I call the traverse recursive function, and I should get the sorted nodes. Let's assume this one is correct. I will come back later if something goes wrong. I'd like to focus on the logic on the main method. So now sorted nodes should be like this. Pointer is pointing to somewhere. Yeah, in a complicated way. But it doesn't matter because all of them should be overwritten. So now n nodes, surely I've used this. Yeah, only twice. So let's don't make it variable. Yeah. So n nodes length is now 3. Length? No. Length of. No, sorry. Let me name it n nodes because actually this is so wrong. So many characters. It's a variable name, I mean. Okay, so n nodes is now 3. And in line 62, oh, this is exactly I would, this 1 to 3 array is exactly the situation in this try run. So when I is 0, sorted nodes I is node 1. 1 dot left should be none. So this is okay. Name it. Okay. Exclamation mark means okay here. And sorted nodes I, which is node 1. And because now I0 is not 2, so sorted nodes I plus 1 is node 2. So yeah, this is met. Okay. Let me write it in this way. This is met. And now I is index 1. So I'm looking at the node 2. Node 2 dot left is none. Okay. Node 2 dot right is node 3. Good. And I move the I. And now node 3 dot left is none. And node 3 dot right is, because index is 2 and end node is 3, this is met, so it should be pointing to none. Good. And that's it. Okay. So I can see the expected tree pointing. The nodes are pointing to nodes dot left and nodes dot right are pointing to exactly what is expected. So I can say this. In this case, I passed. Good. And that being said, I covered all the lines in the main method, so I'm pretty confident on the main method. And everything behaved as expected. Also for the helper method, I quickly check and it looks good. I will come back if something breaks. So let me run my code. Indentation error. What is wrong with this? Ah, okay. Okay. Self.sorted nodes. Object of type none has no ranks. Ah, I see. So now I don't need this. I just have to call this method and it mutates the sorted nodes. Good, accepted. Okay, accepted. Great. So let me quickly wrap up. So today I solved the question, Flatten binary tree to linked list. In this question, I'm giving the root of the binary tree and flattening the tree into the linked list. Yeah. And the approach I took was quite simple. I just did the preorder traversal and put the nodes into the sorted list. Then I concatenated them by pointing the first nodes dot left, or dot right to the next node. And also nodes dot left should be always pointing to none. And for the last node only, node dot right should be pointing to none. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.